Okay. Before we do quadratic equation, we need to know a quadratic function. Yes. So a quadratic function is either we can write it in three forms, though one of the form is the general form of the other two. So the first form, I will use this first diagram to show the first form. This is the first one. So when you are given, as you can see, there is a red spot here. This is the vertex. So assuming you are given the vertex of this, so assuming this point is the vertex, this point, the red point, is the vertex. The vertex is just a point that divides the curve into two equal halves. So let's call the coordinates. Let's call it H and K. So let's here be H, Y, the Y coordinate is K. So any quadratic function given the vertex, the coordinate of the vertex is always Y equals A times X minus H all squared minus K, where HK is the coordinate of the vertex, yes. And A is a constant. So A, H and K are constant, they are numbers. So coming to this one is given, I told you the first one is given the first one is given the vertex. As coordinate of the vertex. Why the second one given the x-intercepts? So where it crosses the x-axis, you can see. But mind you, remember, the quadratic curve is either concave or concave down. Yes. So every quadratic function is always concave. Okay, let me show you concave down. This one is concave. So let me show you. Well, if I don't use some, will assume that the student will assume that it must be concave. So a quadratic function is either concave. This one is concave. Concave down. So the major difference, how do you know when it's concave? Is concave if the coefficient of that x squared, that's when a is greater than 0. That's this coefficient. This a written here. So when it's positive, that's when we have concave. So in these two cases, it will be concave. So while if is less than 0, it will be concave down. So mind you, that's the general. The quadratic curve is always either concave or concave. Quadratic function. So let's go back. So I said the first one is given the coordinate of the vertex. Why the second one is given the x-intercepts. So assuming the x-intercepts, let's use alpha. Assuming it touches the x-axis at alpha and beta. So then the quadratic curve is always y, always that same thing, as x minus the first intercept times x minus the second intercept. So the first one is when you are given the vertex. But mind you, in some question you'll be confused. If they didn't specify the vertex, at that point, this point is the vertex, you better use this. Look at the intercept. So it depends on the question. It's either you use this first one or use the second, depending on the information given. So let's see this question. So they said find the quadratic function. So as you can see, we cannot easily see the vertex That's the point that divides this curve into two equal parts. So the best one to use as I'm seeing the x-intercept, which is at 2 and 6. So now we use our formula, which is y is right, which you know. First one is y. That's the general formula we're going to use. Minus alpha is alpha minus x minus beta. So now from the diagram, the alpha is 2, so minus 2. While the beta is minus 6. Remember, it will be positive or negative, so the curve will be to the other side. So just where you intercept the x-axis, that's the alpha. Now we have a little problem. We don't know the value of a. So the answer, we can't leave the answer in this form. Yes. So we need to get the exact value of a, because I told you a, alpha and beta are constant, they are numbers. So now let's get it. And how do you get it? If you look at the curve there, we have an extra point there. Point A. Yes, that will help us to get the value of A. So now at point A, the extra point given at A, what's the coordinates? 5, 3 over 2. That's x is 5, y is 3 over 2. So now we substitute x as, so wherever you see x, call it 5, or wherever we see y, call it 3. So we still use our function. So we have 3, therefore we have 3 over 2, that's our y, equals a, we are looking for. X is 5, so 5 minus 2, and 5 minus 6. So what do you observe? 5 minus 2 is 3. Y 5 minus 6 is minus 2. So the same 3 over 2, 3 over 2. Y is minus 3a. So what do you observe? Solving for a. Okay, now solving for a, you can see that 3 3's, so we're left with minus half equals a. So a is minus half. And as you can see, remember I told you if the curve is concave down, the value of a must be negative. Remember, check. So you see a is negative. So in case if you get positive, means there is a problem somewhere. Therefore, our quadratic function will now substitute. We go back here. And so you always get the value of a. Very, very important. You need to get the exact value. So we have y equals minus half minus x minus 2 minus x minus 6. So though the answer could be left this way, but we might decide to expand. So let's expand the bracket. So though this could be the answer, but let's expand in case if the answer is not enough. So we're expanding. So opening the bracket, we have x squared minus 8x plus 12. Yes. Yes. So now we have the general. So that, remember I told you we have 3 forms. So we're moving it to the third form, which is the general. If you expand the first and the second form. So if I expand the bracket now, I have minus half x squared plus 4x minus 6. So that's the answer. So it's either this one or this, depending. So it's either this one, the final one, is the same as this. So it depends, especially in OBJ, you know which one is given. So that's it. Let's look at the second question. We are asked to find the quadratic curve. So looking at this, we don't have an x-intercept. Yes, we don't have any x-intercept. So the best one to use is the vertex. And we need to be careful. There's a reason for giving us this grid line, the graph, so that we know how we'll get the quadratic form. So if you check, we'll see that this is the vertex. Yes, you don't assume or you calculate. How do you know this is the vertex? This is the vertex. Why? Because if you check, look at these 2 points. I'm using these points. This is this 3 points. Okay, let me use black. This one. So let's look at this curve line here, from here to here. What do you observe? You see that they have the same distance. From here to here is the same as from here to here. Check. See. 1, let's count. 1, 2, 3. From 5, 1, 2, 3. So that makes this the vertex. So this is our vertex. So this is the vertex of this curve. So let's now solve. Let's get it. Therefore, the quadratic curve given the vertex is always y equals a times x minus h all squared plus k. Where h and k, we've gotten it from this. Remember, our h is 3. If you could remember when I started, our h is 3 and our y, our k, let's check what it is 1. So we now have minus 3 all squared plus 1. Again, we can't leave it this way. We need to get the exact value of a. And how do you get it? We look out for extra points on the curve. So the 2 points I can use is this point, maybe I call it point A. Either I use point A or point B. We get the same as, but I will prefer A because it has the x value smaller than that. So let's use point A. So at point A, x is 1, y is 3. So let's substitute. So wherever I see y, call it what? 1, 3. And wherever I see x, call it 1. So I have 3 equals a 1 minus 3 all squared plus 1. Yes. Y is 3. As you can see, I've substituted y as 3. Y is 3 and x is 1. So 1 minus 3 is minus 2. Minus 2 squared is 4. So I have 4a plus 1. This is 3. So I have 3 minus 1 is 2. 4 is, so a is half. 2 over 4, which is half. So now, we've gotten our quadratic curve, which is y equals half. And as you can see, the a is positive, which is correct. It's concave. Remember, I told you concave. This is a is always positive. So we are very much correct. So we substitute. We now substitute there as half x minus 3 all squared plus 1. So this could be the answer. Now let me use the frame first for this. These points. So we have that the quadratic function is now y equals to half x minus 3 all squared plus 1. Yes. And I've told you it's possible the answer could be written this way, or we'll expand the brackets. So if we expand the bracket, let's expand it. So I have half. The expansion of this is x squared minus 6x plus 9 plus 1. So we now have that y is equal to half x squared. That's an expanding half x squared minus 3x. So half times 9 is 9 over 2. 9 over 2 plus 1. 9 over 2 is 4.5 plus 1, 5.5. So which is 11 over 2. So that's it. So it's either the answer is left in this form or this form. So it depends if it's OBJ. So it depends on the option. You know which one is either this or this. So we've known how to identify that whenever you ask to find a quadratic function. So it's either you use the vertex or use the s coordinate, that's x-intercept. S-intercept, not coordinate. So now look at quadratic equation. So a quadratic equation is any equation of this form, ax squared plus bx plus c equal to 0. So if you notice, when we expanded the function, that's the right hand side, it will be in form of y equal to ax squared something x squared plus something x plus final constant c, which is this. So that's why I say the general quadratic function. So every quadratic function is always every quadratic function, whether given the vertex or the x-intercept, is of the form, is of the general form y equals ax squared plus bx plus c. Yes. So if you check all the answers we got, it's the same as that form. You see it. So that's the general form. So now, for us to have a quadratic equation, what do you observe? Therefore, if y is 0, we now have a quadratic equation. So if you equate that y equal to 0, as you can see. So x squared must not be, from here, a must not be, because if a is 0, x squared will go. So a must not be a number 0, but it could be any other constant, but not 0. So that's its quadratic equation. So we have 3 ways of solving that. The first one is by factorization. The second one is by quadratic formula, using quadratic formula. Why the process is called completing this way, like a proof. And finally, the third method is graphical method. So these are the 3 methods of solving quadratic equation. So let's start with the first one, which is by factorization. That one is the elementary way. So to solve a quadratic equation by factorization, we need to check if the quadratic function is factorizable. Yes, that's if this part is factorizable. If ax squared plus bx plus c is factorizable. Once it's factorizable, can solve using. So how do you know it's factorizable? That's it. That's the main question now. So how do you know that the quadratic equation will be solved by factorization method? So if you notice that b squared minus 4ac is a perfect square. A perfect square is something that has a number that has a rational square root. Whereas a number that can be written as a square of a number itself. Or a number that has would I call it a perfect square root, a rational square root. So that's it. So before you solve, you test whether, because the equation might come this way. The equation will not ask you to solve it. They will just ask you whether it will be solved using factorization. So you don't need to waste time solving it by factorization. You need to test this. Once it's okay, no need to say yes, it's to be solved by factorization. But if they now ask you to solve by factorization, you will solve. So, and in solving it, we factor the quadratic expression. I've said that, and it's by grouping. Yes, then we do it. Well, let's look at this question before we do it. They said, which of the following could be solved using factorization method? Remember, they didn't say solve. They want you to know if you could solve this by factorization, not solve it. Do you get? So you don't need to waste time solving it to know or trying to do trial and error. So I've given you a short form. Say a quadratic function is factorizable if b squared minus 4ac is a perfect square. So what you have to do in each of the equation, locate A, B, and C. Do now plug in the values. It is a perfect square, you know, it could be solved by factorization. So for the first one, what is A? A is 3. A is the coefficient of x squared. B is 8 and C is 1. Therefore, let's test if b squared, which is 8 squared minus 4 times 3 times 1, will give us a perfect square. It is 64. 64 minus 12. What is 64 minus 12? That's 52. So 52 is not a perfect square, not a perfect square, because it will give us a rational square root. So let's take the second. So no, the answer is now what? No. So let's test the second one, which is A is what? Our A is what? So what is A? A is 1, B is 5, and C is 6. So let's check. B squared is 5 squared minus 4 times 1 times 6. So what do you observe? This is 25 minus 24, and it's 1. 1 is a perfect square because it's 1. So you can write the square of any number. It has a rational square root. So yes. Yes. So it will be solved by factorization method. Why the last one? Let's see if it's possible. So see, A is half, B is 8, and C is minus 3. So let's test. B squared is 8 squared. Therefore, we have 8 squared minus 4 times A is half, C is minus 3, which is 64, plus 2 times 3 is 6. So which is 70. So no. The answer is no. Because 70 is not a perfect square. So it's only this second one to be solved by factorization. Now, we've known whether a quadratic equation will be solved by factorization. So let's now solve by factorization. So look at the second example. It says solve the following using factorization. So this one, they know that it's factorizable. So you solve. Though in a real question, they will ask you to solve. Meaning if it's solvable, okay. Though in a real question, they will ask you to solve. Within you now check whether it's possible to use factorization or other method. So, but now they know that it's factorizable. That's why they say we should solve by factorization. So let's solve. So to solve by, if I remember, when I told you that we need to the quadratic expression, we need to group it. Yes. From the name factor, we need to factor and we'll group. We'll factor by grouping. How do you group? If you notice, we'll have 3 expressions here. The quadratic expression. And let's use our basics before we move to this. Assuming you are asked to factor, that you have to factorize. Let me just go to another page to explain that. So assuming you are asked to factorize, it's very important. So factorize maybe 2x plus 8. To factor means bring out the highest common factor in this. That's it. That's what the question said. And we have variable attached to and a number. So we need to compare the two. So between 2 and 8, what's the highest common factor? You know it's 2. Yes. Why there is no x in 8? So x is not a common factor. So that's it. The common factor here is only 2. Then whatever that is remaining in the bracket is the original expression, which is 2x plus 8. You divide it by what you brought out. Yes. Do you get? So to factorize means, look at this, bring out the common factor. So once you've brought out the common factor, the remaining terms inside, you divide it by that common factor. So let's do it. This is 2. 2x over 2 is x. Why 8 over 2 is 4. So, and if you expand the bracket, because expansion is opposite of factorization. So do you get? We'll still get back this. So let's do another one. Assuming you are given maybe 4x squared y and maybe minus, should I use, okay, minus maybe 18x y raised to power 3. Maybe is for x. Okay, let's test this one again before we move to what we have to do. But this is the major thing. If you don't understand it, you won't understand what we're about doing. So again, we have numbers, we have alphabet, that's variables, x and y. Now, between 4 and 18, that's what is the HCF? The HCF will be 2, not 4, yes. And between x squared and x raised to 4, 4. The highest common factor will be x raised to 4, 2. So meaning always bring out the smallest, the power, the smallest power. Yes. So even if it's, assuming this is minus, let me put minus. My here is minus 4. So you know, you see that between 2 and minus 4, which one is smaller? Minus 4, so we have x raised to 4 minus 4. So, and y, maybe, let me put y raised to power 7. So now between, okay, let me put y raised to, so between y squared and y, between 2 and 3, which one is smaller? 2, so y raised to 1. So this is now the common factor of this. So remember what I said before. Now divide the original expression with what you've brought out. About what? What did you bring out? 2x raised to 4 minus y raised to power. So now the answer is still x raised to 4 minus 4y squared times 2, 2. You know, each of them will divide this. 2 to a left to 2. S squared, s raised to power 4. Laws of indices. S squared divided by this. So if this one goes up, it becomes 4. So, or the power of the numerator, which is 2 minus the power of the, so minus 4. It's now 6. Y squared is gone. That's 1. Y squared, y 1, or y raised to power 0, which is 1. We are done. The second one, 18 divided minus, right minus, 18 divided by 2 is 9. So y raised to power, okay, this is x, not y, so this is minus. So again, x raised to power minus 4, they are gone. Y3, so 3 minus 2 is 1, that's 1, y raised to power 1. So that's the answer. Have you seen it? Now, the problem we have here is that we have trinomial. Yes. So we can't easily get the common factor of the 3. So that's the problem we have. So how do you do it? We now use the knowledge of this one we've done. We'll make it 4 terms. Since we will now have 4 terms, we'll group 2, 2. You get? We need to split this middle one into 2. such that if you add up the expression, it still give you minus 11x or minus 19x, or depending on the value or the term that is given. Then we'll now group the two. We now have four terms, which we'll group two using this method I've done here. Using this. So after you factor again, so meaning in this case, we'll factor 2 times. Yes, for us to complete this solution, we'll factor 2 times. So now the problem again we have, how do you split this middle term? How do you split this middle term? Before now, or in a general way, we are taught then, you multiply. Okay, I will do it in elementary way. I will now give you the general way or the easier way. Because the larger the values here and here, the more factors it will have. You know, a number, the larger the number, the more factors the number will have. So the main method, well, I'll give you the best method to use. Assuming I'm solving this 3x squared minus 11x plus 6 equals to 0. I want to split this middle term. So where will you focus? You do these two and for the other two, the one with x squared and the constant. If you multiply the two, it will give you 18x squared. So we'll now split this 18x squared into 2 factors. Yes. Such that their product will give you 18x squared. And the sum will now give you minus 11x. You get the logic? Multiply these 2 terms to give you a term. Like for this first one, give us 18x squared. You now split this into 2 factors that will have x, something x, and another thing x. Such that if you add it up, it will give us minus 11x. So you can see that 18 has a lot of factors, which are 1, 2, 3, 6, 9, and 18. Yes. So we now have 2 factors that will have x in it, and it will be among these. Yes. So the 2 factors will be here. So if I choose 1x, so what will make it 18 is now 18x. And there's no how you combine 1x and 18x to give you 11 minus 11x. You see? Remember, the negative has something to do with the term having the same sign. Yes. So it's either minus x and minus 18x or 1x and plus 18x. Because if you multiply the two, it gives you 18, positive 18x squared. And if you add it, it will not give us minus 11x. So you now see the best to use here will be what? If you check. If I take 11, what will give me minus? If I take 9 and 2. 9 and 2 has something to do with 11. Yes. Since I have 11x, meaning both of them will have negative sign. Yes. So meaning I will split this 11x as what? Instead of writing negative, I'll now write minus 2x and minus 9x plus 6 equals to 0. Yes. Which is correct. But still, we can still write it as 3. You know, you can interchange. 3, thank God this thing came up. 3x squared. I can change just making minus negative 9x to come first before negative 2x. So there is a reason for this. If you check this first one, I can factor this. Remember, I told you we'll factor by group in 2, 2. We'll look at this first 2. We'll factor the common term, the same thing here. But there's a little problem here. We can't factor the number because what is here is 3. 3 and 2 are not related. They are not. 3 is 8 odd. Y2 is only x squared. Okay, let's do it. Let's do something. Let's try it. What is common is x. What will be left here is 3x. And what will be left here is minus 2. Again, what is common here? We'll see. We'll have, what is common is negative Okay, let's take -3. Okay. So what is left is 3x, and what is left is -2. Okay. So we are lucky. If you notice, when I factor -3, if you open up, it gives us this. Again, let's try this equal to 0. So we have what is common in both is 3x. 3x. So what will be left is x minus 3 for this one. Again, what is common in this and this is -2. And what is left is x and -3. So do you see both of them, the two solutions will still be correct? Why? Let's continue. So remember, I told you we'll factor 2 times. We've done the first factorization by grouping. So we have 2 terms here, this and this. So what is common in both is 3x minus 2. Yes. What is here, that is here, is 3x minus 2. So what is left here? This divides this, we're left with x. Why this one divides this, we're left with -3 equal to 0. So let's do the same thing here. What is common is x minus 3. So what is left will be 3x minus 2, which is still correct because multiplication is commutative. This times this is the same words of this times this, so they will give the same result. Like 2 times 3 is the same as 3 times 2, so it will give you the same results. So the final step, for the product of two numbers to be 0, what do you have to say? For the product of two numbers to be 0 means that one of the number is 0. Yes. So for the product of two numbers to be 0 means that one of the number must be 0. Yes. Like 2 times 3 is 0. 2 times 0 is 0. 0 times 2 is still 0. So anyone could be 0, but we don't know the one. So it's either this first one. From our basic knowledge, for the product of two numbers to be 0, either one of the number is 0, but we don't know which one. So it's either the first one is 0 or that second one. So that's same way. Remember, I'm just using this, I'm solving. Next time, just choose anyone and solve. And in some cases, one of them will not be will not factorize. Yes. Like in this case, thank God the two of them, we were able to group it, but there are some questions that one will factor, but the other one won't. So that's why. So we are lucky, both of them here. So now, remember, our main aim of solving is to get the unknown, which is x. So now solving for x 2, so it's 2 over 3, or x is what? 3. So these are the two answers that if you substitute here, the answer will be 0. So in this word, it's only these two answers that will give this quadratic equation equal to 0. The same way here. I told you, just choose one and solve. Just choose one, so 2 over 3. So you won't be solving it side by side. Just take one and solve. So we've gotten the first one. Let's solve the second one. Okay, we are done with the first one. Coming to the second one, observe something. Yes. You see that we have a bigger coefficient of x squared and somehow a bigger constant compared to this first one. So remember, I told you something. Doing this method is not efficient, multiplying the two. Because once you multiply it, you now get a bigger value. And if a number is that large, to get the factors of that number, like 18, 1, 2, 3, 4, 5, 6. So 150 now. If I will do 10 times, negative, this is negative. So it means that the two numbers will have different sign. So, but the actual value, the magnitude, 10 times 115 is 150. So you notice that 150 will have more factors than 18. So that becomes, imagine if it's now the two larger number, maybe a 3-digit or 4-digit numbers. That's why I say this is not efficient, but this is the basic. If the numbers are down. So let's look at this method I'm going to, I will call it trial and error. So even if you try the first time, you can easily know where the factors will from. And the advantage of this method, it will give you the factored answer fast. So it's very efficient in OBJ equation. Yes. We won't be wasting unnecessary time. So now, how do I do that? I will look at these two, the ones, the coefficient, this, the 10x squared, and as here and here, the two numbers. So I will create two factors each with them. So the first one, the two factors that can multiply to give me 10x squared is 2x. Okay, let me use 2x and 5x. Yes, the combination, the product will give us 10x squared. So that I can make the up one to be 5x or negative 2x negative, but most times we make the first one positive. The sign now depends on the second one. So if you look at minus 15 now, you can combine two numbers that will multiply. Yes, to give you 15, negative 15. So it could be 3, 5. It could be 15 and 1. So one will be positive, the other one will be negative. Now, remember I said something. Assuming I take negative 15 and, okay, assuming I take negative 5 and positive 3. Or, let me take the other way, no need of changing sign. If the sign is not what you change. So let's take negative 1 and 15. So let me leave the first one. Let's do the second one, this one. So let's do 2x multiplies 15. Because you know the sign for 15 is plus 15. So let's do 2x times 15. What do you get? You get 30x, right? So now let's do negative 1 times 5x gives you negative 5x. So if you combine these two, what will it give us? It will give us 25x. But what is in the middle is 19x, negative 19x. So it's not possible. Even if you change it from positive 15, even if you make it negative 15 and positive 1. So if you do 2x times 1, it gives you 2x. While 5x times negative to give you minus 75x. Do you see? So it will give us negative 73x. So meaning 1 and 15, they are off. So the one we'll look at, the possible one is this, yes. Because if you do 2x times 3, it gives us 6x. If you do negative 5 times 5, it gives us negative 25x. And you see that 6 and 25 can combine to give me 19, yes. And it's even the answer because negative 19, 6x minus that is now negative 19. But assuming I used positive for 5 and negative for, you now just change the sign. So that's why I say with 1, you can easily adjust and know the answer. But assuming we did 10x squared times negative, they will have a lot of factor 1, 2, 3. Do you get? So it will be very hard for us to figure out. So this is the best way. And I've told you this thing will always give us the factored answer already. So the factored form is this. So this left-hand side is already factored this way, yes. So now you equate each of them to 0. But even if you want to solve it normally, so it has given us how to split. We now split 19x as what? Plus 6x minus 25x. Remember, I told you can interchange. So if you interchange, if it doesn't work, you change. So now, what is common here? Else, JCF of 10 and 6 is 2 is there and x. So what is left is 5x and plus 3. So again, let's check this one. What is common? 5. So negative 5. Since I have plus inside here. Remember, so whatever that is inside must be left there. If they are not the same, there is a problem. You need to swap. So I told you, so the best way to know whether you are, whatever that is here, repeat it. You now use your factorization and adjust. So what will multiply 5x to give you negative 20 is to be negative 5, which is correct. But in some cases, once you've written what is here and you try to adjust it, it won't go. You need to interchange the two factors you splitted. The two splitted this thing that gave us that. So, but in this case, it works. But some cases, it won't work. You now swap. So, do you see it? So, the next one, we've done the first factorization. The second one is 5x. You factor the common term. That's why you need to repeat whatever that is here, so that you can factor the second one. But if it doesn't, you swap here. You go back and swap. So, what is now left is 2x minus 5, which is correct. Remember, equal to 0. You see our factored form. This 2x minus 5. This 2x minus 5. You see, and this 5x. So do you see the advantage of using this method? So, and I've said the product of two numbers to be 0 means that one of them must be 0. So either the first or the second. So x is minus 3 over 5. Or x is 5 over 2. So that's the answer. That's how we solve. The third one. So the third one, if you look at the third one again, we have large numbers. Do you see it? So imagine multiplying negative 42 with 24. We have a lot of factors. That's why I say the other method is not efficient. This one I use is the efficient. But again, but these are different type of questions. These are all the questions you expect will be one of these. Yes. The easier one that you can multiply, the one that is that large, you better use, or you can even use that method here, that method factor that's focusing on this last two, the first and the last, these two, the S3 one. So the third one is somehow difficult than the second one, but not that it's difficult. You need to think outside the box. So if you notice, this is an equation and these are large numbers. So if you see large number, first thing you have to check, is there any common factor that can divide to reduce it more? Yes. So you need to check if there is something you can divide to reduce it more. So as you can see, I think 2 is possible. Is there any other number? Is there? Okay, let's use 2. From here, we can divide each of these by 2. Divide each of the 10. So divide everything by 2, even the right hand side by 2. So what do you observe? Okay, let's divide by negative 2 so that it will turn this to positive. Yes, since we always prefer the first term, that's the one with the coefficient of x squared to be positive, making it 21x squared. This is negative 37x. While this is positive 12. 0 over 2 is. Now, using that our method again, I told you is more efficient. So, which is what? I won't waste time now. So once we factor it, we equate the 2 to 0. So if you look at 21, I would like to use 3x and 7x. And if I look at 12, what is in the middle here? I'm trying to be precise now. Is negative 37. So assuming I make the factors here 12, to two factors of 12. So I can use 1 on 12. You get? I use 1 on 12. But it will be large. It will make okay. 1 on 12. Is it possible? Yes, 1 on 12 is even better. Yes. As I'm seeing 37. 1 and 12. Okay, it's not possible because if I use 1 and 12 here, this is 36 already. 3x times that 36, so it will be more. That 6 plus 7 is 14, but this is negative. So do you get? So meaning that the two, for this to be positive, the 2 must be negative. So if I'm making negative, it will also be the same. To be far, to be minus 43. What is here is minus 37. So the best, let's try 6 and 2 or 4 and 3. So these are the ones that might give us what we are looking for. 4 and 3. If I check 9 and 28, will give us 37. Yes. So 4 and 3 is the best. So I'll use 4 here. Use 3. So since we have positive here, I'll use negative, yes. So if negative 4 times negative 3 is positive 12. Do you see? So it's now possible because if you do 3x times negative 3 is negative 9x. Negative 4 times that is negative 28x. So if they combine, that will give us negative 37. So this thing has factored as 3x minus 4 times what? 7x minus 3. So need of wasting time. So now for this to be, the product to be 0 means this is 0 or 7x minus 3 is 0. So if we solve for x, I have 4 over 3. Or I have 3 over 7. So this one, what we learned in this question is that when the numbers are too large, the coefficient, we need to reduce it. Check whether there is a common factor that can reduce it. Yes. So coming to the last one, if you notice, if you have a fraction, so if any of the coefficients, or if any of the term is a fraction, so what do we do? That's what this last question is telling us. So the next thing you need to do is to make it easier. How do you make it easier? Multiply each of them, because if you want to clear the denominator of any fraction, you multiply each of the term by their LCM. So what will be the LCM of 6, 36, 18, and 1? There, or 0, the denominator is 1. So always continue. So whenever you have an equation, and you want to reduce, you want to clear the fraction, the denominator, multiply each of them by their LCM of the equation. That's both left and right. So as you can see, that 6 is the LCM. So if you multiply each by the LCM, so multiply each of them by their LCM, or just multiply left and right by their LCM. Same 36 times 0. So what do you do? They will reduce. So this 6x squared. Do you see? So we've cleared the fraction now. This is 11x and this is 10 equal to 0. So if you can observe, you see that if you divide each of them by 36, you still get the original expression. But now it's easier. It's better to be left this way. So let's continue. Now apply what we've done. We need to factor. How do you do it? Remember what I told you. 6x squared could be 2x and 3x, or 6x and x, anyone. So I have my negative 10 here. So I'm looking at 11. So how do I get negative 10? Meaning one of them will be positive. The other one is negative. So how do I do it? So if I make this one to be negative, since I have positive, okay, I make this to be 5 and I make this to be 2. Let's check. We notice that 15, I'm trying to be precise now, yes. That's why I say it's try and error. You see that this 15x and this is 6x. And 15x minus, okay, it won't go. Okay, this is 4, not 15, not 6, sorry. It will go. You see, it will result to 11x. So now instead of writing this, I'll write 2x plus 5. It's what? 3x minus 2 equals to 0. So this is very efficient now, solving for x, equating each of them to 0. I've told you why. The product of the two numbers to be 0 means that one of the numbers must be 0. It's a must. If not, it can be. The answer will not be 0. So we now solve for x. This is negative 5 over 2 or 2 over 3. So that's how we solve quadratic equation by factorization.
So find values of x for which 8 root x minus 15 is equal to 0. So what I will do, I will let, since I'm seeing square root, so let's call root x to be y. So what do you notice? We now implies that x is now y squared. That's squaring both sides. So we now go back. So I have 8 times y minus y squared minus 15 equal to 0. Yes. So I substituted this. So which is, we'll move this to the right hand side. This is now y squared plus, okay, let's first write minus 8 minus 8y plus 15 equal to 0. So I've, or maybe I multiplied all by minus, as minus 1. So what do you see? We have a quadratic function, and if we factor this, this is y minus 3 times y minus 5 equal to 0. So we have that y is either 3 or 5. But we're not asked to find y, we are given x. So when y is 3, implies that x is now 3 squared, which is 9. And when y is 5, so it implies that x is now.
To do some, we need to analyze something to help us to understand that completing the square, because students find that method, that's once you ask to use completing the square, like to prove, to show you're working using, I told you both of them are the same quadratic formula, and they are the same. Completing the square is just a process of the solution. That's the real analytical solution to getting the formula. So now, how to make a quadratic expression a perfect square. So let's start with a perfect square expression. If you could remember, I told you a perfect square is anything that could be written as square of a number itself. Yes. Now, if you have the brackets, what do you observe? You see that that's what you get. So once you expand this, that's what you get. It will have 3 terms. It will always have 3 terms. And these last two are perfect squares. That's the extreme ones are perfect squares. And this middle one, remember why this is positive, this is positive. So the sign of this determines the sign. But the first and the last are always positive, because square of numbers are always positive. So the sign here, the middle term, that's the sign of the middle. If it's negative, it's negative. So this is, you notice that the middle term will be 2 times the product of the first term. That's the square root of the first term. 2 times the square root of the first term. That's square root of a, which is square root of a squared, which is a, and square root of b squared. So this is very important. So the plus or minus depending. Now let's go back to this. Let's go back to this. We want to get an expression, a formula, expression, so that we won't be wasting time when you are asked to get something like this. So they now say, how to make a quadratic expression a perfect square. So let's now, a quadratic expression, now let's focus on the first two. So look at this picture. If someone asks you, what will be added to maybe as squared plus or minus bs, is a quadratic expression, to make it a perfect square. So this means, let's move it to an equation or mathematically. Let's express that. So they said, what will you add as squared plus bs? What will you add so that you have something squared? That's the meaning. So this is where remember plus or minus. This is where this thing I've done will help us. See, if you look at this first one, this one, you notice that the first and the last are perfect squares, so there must be perfect squares. So for this expression to be squared, it must have 3 terms, and the first and the last must be perfect square. But here, if you notice, a square is not affecting a. Yes. So what do? We need to make it something squared. It must be something squared. The first one, let's leave the middle one. And the last one will be again something squared. Let's call it k. So now we want to add k squared. So we now add k squared to make it a perfect square. But meanwhile, this first one should be something all squared. And to avoid changing the expression, it should be roots. So it's now roots to be roots ax all squared, which is still correct because root a all squared is a, x squared is a squared. So still, you don't know something all squared, but we know it must be plus or minus because this is plus or minus. So, but from our definition, so we are settled with the first and last, yes. Squared, k squared, but we don't know the value of k. Let's get k. And how do you get k? For this to be a perfect square, we are settled with as from what we are saying, the first is square, a perfect square, the last is perfect square. Therefore, this middle one, which is bs, must be 2 times the square root of that is this square, as you can see, the a here. So what is here? A means square root of a squared, which is a. And b is the other thing that is carrying the square. So now the middle term must be 2 times, which is from here. The middle term is bs. Whatever that is here must be 2 times this one and this k. Yes, 2 times this and that. Yeah. Yes. With that, we'll form an equation and let's solve for the unknown, which is k. So once we get the k, we square it. That's the answer. So as you can see, x is common. We cancel out x. We now have 2 roots a, k. Therefore, solving for k is now b over 2 roots a. So remember, this is a k, which implies that k squared is now squaring both sides. B squared is b squared, 2 squared is 4, and root a squared is a. So we've gotten an expression. Now we always add this to make a quadratic expression. This quadratic, so that's how they will ask it. What will be added to this to make it a perfect square? Now, to complete it, because we are coming, now, generally, we always add b squared from what we've gotten over 4a to make as squared plus bs a perfect square. So that's the one thing. Now, what will be the resulting perfect square? Like what will be in the bracket now? What will now be that will carry the 2? So how do you get it? Let's go back to our original. You notice that whatever is like now, we are giving the right hand side to move it to the left hand side. So now you notice that whatever that is left here, the 2 terms in the bracket will be square root of this and that. Square root of a squared is a, square root of b squared is b. Do you see it? So now let's complete it. Therefore, a perfect square, which is this, a quadratic function, we need to add b squared over 4a so that it will have, remember, plus or minus. So whatever that is inside will now be square root of this, which is root as, and square root of the other one, the other term, the last term, which is what? b over 2 root a. So that's a very important, because they might ask you complete the expression. It is very, very important. So aside knowing what will be added to make it a perfect square, so we need to know the resulting perfect square. So let's look at this question now. Okay, look at this one first. They say complete this. Okay, this is example. Okay, let's do example 1 first. This is example 1. They say what will be added to the following quadratic expression to make it a perfect square. So like what I've said, all you need is to know a and b. Yes. So we always add what? B squared over 4a to make a quadratic, to make as squared plus bs a perfect square. So now the first one, you can see the first one, what is a? So now the answer will be, what is b? Okay, we have b squared. B is 1, coefficient over 4 times a is what? 1. So the answer is 1 over 4. So that's it. They didn't ask us the resulting perfect square. Why the second one? What is b? Minus 5. All squared over 4 times, what is a? Minus 2. So we now have what? So always add what? This is now 25 over minus 8. So that's what we add to it to make it a perfect square. You see, so we always add 25 over minus 8 to make that a perfect square. Now, look at this. They say complete this expression. So as you can see, it's the same thing that we did now. It's the same thing. Add this. So what will be added to that, which is minus 5 over 4 times what? 3 to make it a perfect square. So let me just erase it and write it well down. So add is 3x squared minus 5x. We add minus 5 all squared over 4 times 3 to make it a perfect square. So, and the resulting perfect square, since this is negative, square root of 3x squared is root 3x. Let me just, this is now root 3x, yes. Since you have negative, why this is square root of 25 is 5. Square root of 4 is 2, that's 2 root 3, all squared, that's it. So the unknown here is root 3. The sign is negative. Y this is 5 over 2 root 3. Y here is 25 over 12. Yes. So this is 25 over 12. So that's it. So it's very, very important you should know this. This will help us. You'll see the reason later. Because if you look at the left-hand side, it has many terms than this one. This one is concise. And you can easily solve for x on the right-hand side than on the left-hand side. Yes, it's easier to use this one than this. You see reason. That's why we said completing the square. So let's
if 8x squared minus 2x plus m equals nx plus p all squared, then m plus n plus square. So we are going to use the knowledge that given a quadratic function ax squared plus bx, that if we add b squared over 4a, it will be a perfect squared. Yes. So whenever you add b squared over 4a to a quadratic function, that's ax squared plus bs, it will turn to a perfect square. So maybe plus or minus. And the perfect square that we'll get, if there is plus here, we'll have plus. If there is minus, we have minus. Why the two values that will be here will be the square root of as squared and square root of b squared over 4. So square root of ax squared is root ax, while square root of b squared over 4a is b over 2 root a. So that's the knowledge. So here we can see that 8x squared minus 2x will add, what is b here? B is minus 2, so we'll add minus 2 all squared over 4 times 8. A is 8. Do you get? It is 8. Why b is minus 2. So, and what will be the value that we'll get? So here the square root of this is root 8x. We have minus. Why the square root of this is 4? Well, so square root of that is 1 over root 8, which is root 8 over 8. Yes, 1 over root 8. That's the square root of this, all squared. So what do you notice? We'll see that, therefore we'll see that m is 1 over 8. That's this. N is root 8. And p is, since we have plus here, so we now see that p is minus root 8 over 8. So we're asked to find m plus, so we have, therefore we have m plus n plus p is 1 over 8 plus root 8 plus minus, that's minus root 8 over 8. And this is now 1 over 8 plus root 7 root 8 over 8. Yes, root 8 minus root 8 over 8 is 7 root 8 over 8. So this is now 1 plus 7 root 8 over 8. So it's not in the option, but we can still simplify. So now we know that root 8 is 2 root 2. And 2 times 7 is 14. So 14 root 2 over 8. So that's the answer, which is option B. So it's a tricky one, but it's still simple. Thank you.
Okay, for which the expression is a perfect square. Now, using our knowledge, now this one is different. They gave us, remember, A is now this. So look at this. Let's divide the equation to take us time. So look at from the expression, our A is 3 plus 2k. That's coefficient of minus 1. So what's A? A is 3 plus 2k. That's coefficient of x squared. YB is minus 6. Yes, coefficient of A. C is now 4 minus k, which is what we will now add. Yes, remember, quadratic expression is always as squared plus or minus bs. So the one they added already now is 4 minus k. So we are not saying, let's just leave it. So remember, for this expression to be a perfect square, we always add what? B squared, which is minus 6 all squared over 4 times A is 3 plus 2k. That's what we add, but they have added it already, which is now 4 minus k. You get the logic. So whatever that is remaining here, this part, that's what we added, should be the same as B squared over 4a, which is minus 6 squared over 4 times 3 plus 2k. Now we can solve for our unknown. Yes. So 36 over 4, this is 9. Oh, so I have 9. That's that minus 6 squared is 36, 9 off. So this one will cross over to multiply 4 minus k, 3 plus 2k. So again, we'll expand the right hand side is 2 off minus 3k. Okay, let me just write minus 3k. And the other one is plus 8k. Finally, minus 2k squared. Okay. Now, remember, we are forming a quadratic equation, meaning k will have 2 answers. So if we move everything to the left-hand side, so it's we have positive 2k squared. So here is minus 3k plus 8k is plus 5k. But if we move, it becomes minus 5k. 12, if it moves, now 9 minus 12, which is minus 3, equal to 0. So we'll move everything on the right hand side to the left hand side. Now, as you can see, since this is factorizable, yes, since we are still on factorization, we've not done this NECO and the third method. So this could be factored as, let's check, 2k and k minus 3 and plus 2. So I have minus 3 here and plus 1. Yes. Check it. This minus 6k plus k is now minus 5k. So I factored it already. And this means either this equal to 0 or that equal to 0. So solving for k, and I have is minus half or is what? 3. So these are the two values of k that if you put here, this thing is a perfect square. So it's a very tricky question, but it's still simple. So let's now move to quadratic formula proper. That's completing the square. You now see where this thing will help us. Yes. Okay, now let's move to completing the square, like proving the quadratic formula. Now, if you check from this right up, to solve a quadratic equation using completing this way will make the quadratic function a perfect square. Do you see? That's why I had to treat that making a quadratic formula, making a quadratic function a perfect square. Then we solve for the variable. You know, the unknown there is the variable, which is x. So how do you do it? Remember that we always, that's every quadratic expression, ax squared plus bx, we add b squared, we add b squared over 4a to make it a perfect square. Now I've told you what will be left is the square root of the first one, whether plus or minus. Remember, I told you plus or minus b over 2a. So that's it. And if you look at these two, it's easier to work with the right hand side than the left, because remember, to solve a quadratic equation is to solve for the unknown, which is x. And if you look at the left hand side, there is x squared and there is x. So it's not easy to solve. We need to split it. You get it takes time. But if you check the right hand side, there is one, we have only x, yes. So to solve for x here is easier. So I need to move the square to the other. Do you get it? So what will I do? So whenever you are given a quadratic equation, I will make it to look like this, a quadratic function. So add something so that it will turn to a perfect square. So everything here will now replace it with this. So that's from the name, completing the square. You are adding it so that it will be a perfect square. So let's start. So before now, we know that generally a quadratic equation is always in this form. Every quadratic equation is always ax squared plus bs plus c equal to 0. Yes. Now let's solve. We are looking for x. Now, if you could remember, we'll make the quadratic expression a perfect square. So let's make it to be only a quadratic expression by moving c to the other side. It becomes minus c. Remember, check. What will be a quadratic expression? Check. What will be added to something like this? This is see the quadratic expression. So that's what I'm doing now. So let's make it look like only quadratic expression, though it's an equation. So let's focus on the left-hand side. Now, to make it easier, you know the first one I solved, then this, all will be added to this. It was easier to solve the first one than the second one because the coefficient of x squared is 1. So it's easier, but this one, you have to do this one. Once you look at it, you can see the answer, but here I need to. So let's make it easier by making the coefficient of x squared 1. Since it's an equation, it's easier to make. How do you do it? Divide both sides by a. So if I divide everything here by a, so we now have x squared plus b over a. So now our coefficient of x, like in the other one, our b squared is now b over a. Because the coefficient, b is the coefficient of x, yes. So you beat anything, it must be coefficient of x. So in this case, our b is b over a. Now, on the left-hand side, we have a quadratic expression. So how do you make it a perfect square? We'll make x squared plus b over ax a perfect square by adding what? The coefficient, that's our b is now b over a. B over a all squared over 4 times again. Over 4 times what? Which is 1. Here, our coefficient of our a now is now 1 because I told you coefficient of x. So there's a reason for that so that it will be easier. working with A is not that we won't get it, but it will be easier. It will reduce stress. And since we have an equation, whatever you do to the left, you do it to the right. Yes, we can't leave it this way. If you leave it this way, we've changed the equation because what they gave us here is just 210. We added this, though we have ulterior motive of adding this. So now we still add the same expression to the right hand side, making it to be correct in both. Making the equation between us not to change the equation. So now you've observed that this part, this left hand side is now a perfect square because we've added something. So our answer will be, instead of using all this, I will replace it with a perfect square. Yes. So that's the essence of this thing we've been doing. That's the essence of this. Replacing this with this, that's the first. That's that's the target. Replacing these three terms, add something so that it will turn to this. So instead of using this one, we use this, it's easier. So that's what completing the square is all about. So if you don't understand the addition of something to a quadratic expression to make it a perfect, you can't understand the perfect square. You can't understand completing the square. Now the value here is plus, so it's always plus. So square root of x squared is x. Y square root of this, square root of b over a, all squared is b over a. Y square root of 4 is 2. So I now have b over a over 2, which is b over 2. Do you get square root of this expression? Square root of this, square root of b over a, all squared is b over a. Y square root of 4 is 2. So b over a over 2 is now b over 2a. So do you see it's easier now? Instead of using this, I'll replace it with this. So why this? I'll just expand the brackets. Because this one, that's our target, to replace all these three with this. But this one will continue in the normal way. Expand it. We now have b squared over a squared over 4, which is b squared over 4a squared. Now, remember, we are solving for x. That's our unknown. That's what we are solving for. The unknown in quadratic equation is x. So let's solve for x. Now, the first thing I have to move when we're looking for x is to move the square. So whatever, and meanwhile, the right hand side, the LCM is 4a squared. So this in this, I have minus 4ac, and I have plus b squared. Yes. Now, if I have this all squared first, all squared. So next now is to solve for x. So I'll first move the square to the right hand side. And if you move square to it becomes square root. So I'll prefer writing, since I have negative number before posing, let me write the positive. It's still the same thing. Minus 4ac over 4a squared. Now, we can see that 4a squared has a perfect square, which is 2a, but this one has no. So they are the same. But remember, square root of any number must be plus or minus. Yes. Do you know why? Let's use, if someone asks you minus 5 squared now, the answer is 25, right? If someone asks 5 squared, the answer is what? 25. So if now say someone, if we want to move from right to left now, means the square root, right? So if someone says square root, the square root of 25 is plus 5. It's still correct. If the person says minus 5, it's still correct. Because if you multiply minus 5 2 times, gives you 25. If you multiply 5 2 times. So that's why the square root of any number must have two answers, plus or minus. So that's why we introduce the plus or minus. So now, the second to the final step, we are looking for x. So that plus b over 2a crosses to be minus b over 2a. We have plus or minus of b squared minus 4ac over 2a. Now, what is common? You can bring all in the same denominator, which is 2a. Why this is minus b plus or minus square root of b squared minus 4ac. So this formula is what we call quadratic formula. So the final answer that we got, so this x equals minus plus or minus that over 2a is called what? Quadratic. That's what you call quadratic formula. So why this process of doing that is called completing the squares. Yeah. We are asked to solve the following by completing the square. So now we are not told just to solve. They told us the method to use and the process. So we need to complete the square. Let's see. So the first one, we have 3x squared minus 5x minus 1. If you follow the steps, so the best thing I did is to move the constant term to the other side. So from negative 1 to 1 now. So I have 3x squared minus 5x. So next thing is to divide both sides by 3. So I have. So next thing now is to add something on because our target is to make the left hand side a perfect square. So we'll always add minus 5 over 3 all squared over 4 times 1. Yes. And I've told you once you add the same, whatever you add it to the right hand side. So avoid changing the equation. So I've added the same thing. So now the left hand side will be a perfect square, which is now something squared. And I have a negative, because the sign here is negative. Square root of x squared is x. Y square root of 25 over 9 is 25 over 3. Yes, because this is 25 over, numerator here is 25 over 3 over 2 is now 5 over 3 over 2 is now 5 over 6. So that's it. Why this one? I told you open up this plus 25 over 9 times 4 is 36. So here the LCM is 36, which is 12 plus 25. So this is 37, yes. Over 36, remember the same. So now we move the square to the right hand side. So the square root is now plus or minus 37. Square root of 36 is, square root of 36 is 6. So the next one is to move, the next step is to move. So I have x minus 5 over 6 to be plus or minus 37 over 6. So we move 5 over minus 5 over 6 to be plus 5 over 6 plus or minus 37 over 6. And this is 6, 5 plus or minus 37. And you know this means two answers. Yes, means the first one is the positive, has taken the positive sign, or negative sign. So that's the meaning of it. That plus or minus, that's the answer. So why the second question, has a radical in it. So the second one, the same procedure. So we move that to the other side to be positive 7. So now divide by root 7. Root 7. This is 1. Now, before we do anything, let's rationalize. So multiplying by the conjugate, I want to rationalize this so that there will be no radical in the denominator. Multiply by 7, so I have 6 root 7 over 7, yes, x. So I've rationalized it, they are the same. If you know your solid or radical. So now, let's add up something so that it will be a perfect squared. So always add minus 6 root 7 over 7 all squared over 4 times 1. The same thing, we add the same, which is minus 6 root 7 over 7 all squared over 4 times 1, which is 4. So this one is now a perfect square. What is left is x here, negative. What's square root of this? So the square root of this will be 6 root 7 over 7 over 2. So the 2, 6 over 2 is, do you get? Square root of all this will be 6 root 7 over 7 over 2. So the 2 will cancel 6. So I have 3 root 7 over 7 all squared is equal to this 1. We expand this one. 6 squared is 36. Root 7 squared is 7. 7 is 49. So I have 36. Do you get 6 squared? That's negative 6 squared is 36. That's the 36. Root 7 squared is 1 over 7. So that's 6 over 7. The 7 multiplies the 4 there is to be 28. So that's it. So now you see that 4 in 36 is 9. 4 in this is 7. Why this is x? The same thing. Let's just make this one. So let's move to the next page, which is x minus 3 root 7 over 7 all squared is equal to, remember what is here is, let's check, this 1 plus 9 over 7 will be 16 over 7. So this is 16 over 7. Now the square will move to the square root. So it's now plus or minus. Square root of 16 is, square root of 16 is 4. Why this is root 7? Why this is x minus, that I can write this one as, okay. Let's just continue. 3 root 7 over 7. So this one moves to be positive 3 root 7 over 7 plus or minus 4 over root 7. And if you rationalize by multiplying by root 7 up and down, 4 over root 7 rationalize is now 4 root 7 over 7. So now this means two answers. The LCM, that's and as you can see, this has two answers, the addition and the subtraction. So it's either is 3 root 7 plus 4 root 7 over 7, or 3 root 7 minus 4 root 7 over 7. So if you add this one, we have 7 over root 7 over 7, or minus root 7 over 7. And if you look at this, this is 7, this is root 7. So x is either root 7 or minus root 7 over 7. So this equation is based on both radical source. So you need to be conversant with source. We need to solve to the lowest level possible. Okay. We want to learn how to find the vertex of a quadratic function. If you could remember, I told you a quadratic function could be written as in terms of the vertex, y equals a times x minus h all squared plus k, where h comma k is the coordinate of the vertex. Now, again, I've told you that the general equation of a quadratic function is always as squared plus bs plus c. So why we have to learn this? Because it's possible they will give you this. That's if you expand. I told you these two are the same. We expand this. Once we expand this first one, it gives you the second one. Also, the other form, which is in terms of the x-intercepts. So the question will come this way. They will give you this expression, the function, ask you to find the vertex, meaning you should transform it to this form. That's go back to this form. Then whatever that is here becomes the vertex. Yes, h and k. And if you notice, this is a perfect square. Yes, x minus h all squared. So we now use the knowledge of this, knowing one of the forms of the quadratic function, that's in terms of the vertex, and also transforming this to be a perfect, that's working with completing the sphere, adding something to make a perfect sphere. So we combine this knowledge to get a general formula. We won't be wasting time solving, especially if it's an OBJ question. So I want to transform this back to this. So if you look at the first one, you see that the A is outside. Yes, A affects both X and A, but here A is affecting only. So I need to, how do I do it? I'll bring out A first. So I have A x squared plus B over A x plus C over A. So we are still correct. Now, I need to make this one a perfect square. Yes, this two is a quadratic function now. Expression A, if you remember, A squared plus BS. So let's focus on this. So how will I make it a perfect square? Remember, we always add what? The coefficient of x, which is b over a, all squared, over coefficient of which is here 1. You see? So I'm using that knowledge. What will be added to a quadratic expression to make it a perfect square. So this is a quadratic expression. I'll add the, but remember, we've changed the equation by adding this. Yes. So what do? Let me just write this c over a, but I will still counter it by subtracting the same thing. So nothing has points. So I've neutralized the effects by subtracting the same thing. So that this and this are equal. So we're heading to somewhere. So if you check now, this one is now a perfect square. Yes. So whatever that will be left inside the bracket will be square root of this x squared. Since it's plus, you write plus square root of that. So I have x, square root of x squared is x plus square root of this will be b over 2a. Check. Square root of this is b over a. Y square root of 4 is 2. That's it. All square. So this is already a perfect square. So all these three expressions now. All these three terms now this one expression. So why this one? You don't care. You need to expand. We expand this. I have b squared over a squared, which is over 4a. So that's it. Now we're getting to somewhere. If you notice what the sign here is negative, while the sign here is positive. So what do? You make it negative and attach the negative to this. all squared is C over A minus B squared. Or maybe let's bring these two to now the final step. So open back, yes. We need to open back. Therefore, the function is now y equal to A times this is now X. You get this times this now. A is just affecting this one, which is X minus B over 2A all squared. Y A times this is C. A times the other one is B squared over 4A. So what do you observe here? Can you compare? What do you observe? You can see that compare, you see that H will be minus B over 2A and K is C minus B squared over 4. So the coordinate of the vertex is minus B over 2A, comma C minus B squared over 4. So this is the coordinate of the vertex. So given the general equation, so I've derived that. So before we solve this, let's relate it to maximum and minimum. Yes. So look at this, the minimum and maximum value of a quadratic function. So it has something to do with the vertex, yes. So if you notice, we have to, I've said it before, the quadratic function is either concave up or concave down. So if it's concave up, we have a minimum, yes. What we have here is what? We have a minimum. So this one will have a minimum, but as you can see, the vertex here is below, while this one is there. So we'll have that minimum value, but y here will have maximum. And what do you observe? The minimum value will always occur at the vertex, yes, which is hk. So h is minus b over 2a, yk. K is now C minus B squared over 4A. Now, if you notice, we are talking about value. So the K, this is the value. The Y coordinate is the value. So both the maximum and minimum occur at the vertex. So this is H equal to minus B over 2A. Y, this is K equal to C minus B squared over 4A. So both of them will still occur, whether maximum or minimum, occur at the vertex. It's just the sign of A. You know, A, this is, if A is greater than 0, we'll have minimum. So that's the difference. And the value, we are talking about value. Once we hear value means the Y coordinates. So now this is the, here, this is the maximum value. So this is always the minimum. Y, so K is always the value. Y the points. This is now this is the maximum points. So once you talk about value is the Y coordinate, which is K. Just know that. So I had to do this before we solve these questions now. Find the vertices of the following. Okay, as I've said before, the vertices, if you are given y equals s squared plus bs plus c. So the vertex is, the coordinate of the vertex is minus b over 2a comma c minus b squared over 4a. I'll prove that. We've gotten a general formula for that. So for the first one, what is B? So my vertex is now minus 8, 2 times 3, comma, 1 minus 8 squared over 4 times 10. So which is this minus 4 over 3, comma, is 60, that's 16 over 1 minus 16 over 3 is 1 minus 16 over 3 minus 3, that should be minus 13 over 8. So that's the answer. That's the vertex. So why the second one? The same thing. B is what? 8. So I have minus 8 over 2 times A. A is half. Comma. The other one is 3. That's minus 3. And C is minus 3 minus that's 8 squared minus 8 squared over 4 times 5. So this is 2 to 1. So I have minus 8, comma. This is 2 to left with 64, 32. So minus 3 minus 32 is minus 35. Yes, you are correct. Very much correct. If you doubt, we can sketch the curve. Let me just use this let me sketch it so that you see that we are correct. Let's know whether we are correct. The vertex. I'll just type it. Okay. So I'll type it, it will drop. So let's type y equals, the other one is 3x squared. Let's check. 3x squared plus 8x plus 1 plus 8x plus 1. So let's check. So the vertex, what do you observe? The vertex. We got what? Let's check what we got. Minus 4. X is minus 4 over 3. That's minus 1 point something. Let's check. You see, here is minus 1 point some 333. Y, the K, that's K now. The Y coordinate will be minus 4 point something. Let's check. That's minus 13 over 3 is minus 4 point something. So do you see we're correct? So why the second one is, I think it should be half x squared. Half x squared plus 8x minus 3. Yeah. Okay. Do you see it? Do you see minus, our k is minus 13. Why? The x value, you see it? It's half of that. Check. So between this and this, each of them does 5 over 5, 6, 7, 8, 9. So 1 should be minus 8. I think it's minus 8. Let's check. You see? So we are correct. Correct. Okay, maybe you're not seeing this. Okay, let me move it. Sorry, you see. Okay, I can't move the other side. so that you can see the equation. Okay, you see the equation. So that's the thing. So we are correct. So we are correct using, so the same way now, if we are asked to find the maximum and the minimum, so both the maximum and minimum, you say, okay, look at this question now.
Okay, we have two forms of quadratic function. So the one that is either concave up or the one that is concave down. So, and every quadratic function is always equal to, as y equal to a times x minus h all squared plus k, and this is the vertex. The vertex this. So this is hk. This is hk. And the mass for this will have a minimum. To have a minimum value, while this will have a maximum value. So the value is k now. K is the maximum. For here is maximum, is minimum, while for here is maximum. So while h is the point where it occurs. So since they are asking us the maximum value, we are looking for k. So if you look at this equation now, and how do you know it's concave up and concave? This is when a is greater than 0, while this is when a is less than 0. So it will have a maximum if a is less than 0 and a minimum if a is greater than 0. So from here we can see that from here a is minus 3, so it will have a maximum value. That's why they ask us maximum value. And h is 2, while k is minus 5, and this is the answer. So every quadratic function, k is the maximum or the minimum value depending on the shape. So our answer is option A. So that you don't need to waste time expanding. Thank you. So let's find the maximum value of this. So for every given quadratic function, that is y equals ax squared plus bx plus c, the maximum or the minimum value is c minus b squared over 4a. So the formula for it, if you are given y equal to ax squared plus bx plus c, the maximum value is c minus b squared over 4a. So that therefore for this we see that the maximum value is c, or c is minus 11 minus b squared. B is half, so half squared over 4 times a is minus 1 over 16. Yes, so this is minus 11 minus, this is 1 over 4. This is also minus 1 over 4. So 1 over 4 divides 1 over 4. We are left with 1. The minus, so minus divided by minus is plus. So our answer is minus 10. That's option B. So that's the formula for the maximum or the minimum value of a quadratic function. Thank you. So we are given this. We should know that the maximum or the minimum, that's the maximum or the minimum value of a quadratic function y equal to ax squared plus bx plus c is c minus b squared over 4a. So that's the formula. So from here they gave us that the minimum, this minimum value is -7. So -7 is equal to C. So here C is 13. So I have 13 minus B is minus B. So I have minus B all squared over 4 times A is 5. So this is now equal to this -7 equals this 13 minus B squared over sorry this B looks like 5. So B squared over 20. So from here we come like we move minus B squared over 20 to the other side to be B squared over 20 equals 13 plus 7 is 20. So B squared is now 20 squared. Therefore B is 20. Okay, since square root, B is square root of 20 squared. Since I'm not, there's no 20 here. So the answer is plus or minus 20. So the answer is option C. So that is it. Thank you. A quadratic function which takes a value of 2 at x equals -3 and the value of 11 at x equals -4 is minimized at x equal to -2 is dashed. So the first thing we have to know that every quadratic function, whether concave up or concave down, okay, let me draw 2 different curves. So this is concave up, while this is concave down. So the function is always y equals 8x minus h all squared plus k. So the same thing. So where hk are the coordinate, that's hk is the coordinate of the vertex. So the same thing hk. So using that knowledge to solve this question, so we have y equals 8 times x minus h all squared plus k. So they told us that the value of 2 at x, so y is 2, at what? X equals -3. So x is -3 minus, so like it, x is minimized, so h is what? -2, because the total is minimized. So this is the minimum, this is where the minimum value, that's the point, whether value or point. So meaning h will be -2, which is +2 all squared plus k. So if I solve these 2, this is -1 squared. So -1 squared is 1 plus k is 11. So y is 11 at x equals -4. And it is minimized at -2. So -2, h is -2, so +2 all squared plus k. So I have 11 equals this 4a plus k. So we'll call it equation 2. So if we subtract, so let's do equation 2 minus equation 1. We see that 11 minus 2 is 9. 4a minus a is 3a, and k minus k is 0, so which implies that a is 3, 9 over 3, which is 3. So we choose any of them to get the value of a. So if I choose equation 1, so if we substitute, therefore we have that 2 is equal to a is 3. So that implies that k is now 2 minus 3, which is minus 1. So we'll now go back. We've gotten all the unknown. So the equation, the function is now y equals a is what? 3 times x minus 2. Remember them. So minus 2 is plus 2 all squared plus k. K is minus 1. So which is 3. This is x squared plus 4x plus 4 minus 1. So this is y equals 3x squared plus 12x plus 12 minus 1 is 11. So this is the quadratic function. So that's the answer. That should be option C. So it's a tricky one, but still simple. Thank you.
Okay. Graphical method of solving quadratic equations. So we know that before now that the quadratic equation is any equation of this form: s squared plus bs plus c equal to 0, where a is not 0 and a, b, c are constants. Now, looking at this, we have two functions, yes, because we cannot just plot this. So we use what, from the knowledge of what we saw, this means y equal to a squared plus bs plus c, and y equal to c. Yes, if you remember, this is a quadratic function.